Okay, so this is also from F325, June 2011, and this is question 8, one of the long answer questions. So you're given a mass of information at the start, and then you're given specific instructions on what to work out. So for steps 1 to 4, write on equations, including state symbols for the reactions that are taking place. It's worth having a look at step 3 as well, just to have a think about what's happening there. And then determine the percentage by mass of the copper in the brass and give your answer to 1 decimal place. So that gives you the precision that they're looking for there. So just work through these step by step. None of the chemistry here is particularly complex. It's just a case of marshalling all of the information together and then making sure that you don't make any silly mistakes. So the first one, we've got two half equations. So obviously, if we're going to work out the ionic equation, we need to make sure these half equations are balanced. So you've got copper going to copper 2 plus and 2 electrons, and then here you've got the nitric acid just using 1 electron to make a nitrate ion, the nitrogen dioxide and the water. So these two need balancing and then adding together. So our copper, and we'll put the state symbols in afterwards just to speed things up a little bit. 2 electrons there, and then you've got to double what's going on here to make sure our electrons balance. So 2 lots of HNO3 plus 2 electrons, and then put that all in. You've got 2 nitrates, 2 of the nitrogen dioxides, and then 2 of the waters. So if we add these two together, adding these two together, we'll end up with the 2 electrons cancelling here and here, and then notice that we've got 2 nitrate ions here, and in solution, which we will end up with because we've got some water, one of our nitrates here will cancel with one of our nitrates here. So in fact we've got 4 nitrate ions, 2 nitrate ions here, so these will cancel out. So overall, if we just write it all out, let's do it down here, give us a bit of space. 4H plus and then 4NO3, because these will be separated out, and then our 2 electrons will give us copper 2 plus and 2 electrons, and then 2 NO3 minus and 2 nitrogen dioxides, and let's balance that one, 2 waters. Okay, and then cancelling out, we've got 2 electrons here and we've got 2 electrons here, so those two cancel, and then you've got 2 nitrate ions here and you've got 4 nitrate ions there, so that one becomes 2, and so our final equation is copper plus 4 hydrogen ions plus 2 nitrate ions becomes a copper 2 plus and then 2 nitrogen dioxides and 2 waters, and then if we put the state symbols in from the original, we'll end up so although it does say include state symbols, I've just had a quick check of the mark scheme, and it's actually in this case said ignore state symbols throughout, which is one of these oddities between when the paper is written and when the chief examiner and his senior examiners get together and look at it, and they've obviously decided not to mark on there. So the final equation on this one is this is the one that we would have ended up with here. So moving on, so that's step 1. Step 2, excess sodium carbonate is used to neutralise any acid. The mixture effervesces and precipitate forms. So we've got sodium carbonate neutralising acid, so we're going to be having a reaction between hydrogen ions, which is the acid, and carbonate ions, and this is, or should hopefully be, very basic chemistry for you. H2O, and then we've got 2 hydrogen ions required here, and then that should all balance through, and in this case we will just put the state symbols in just for completeness. we've got aqueous carbonate there, and then that's obviously a gas, and water is a liquid. So that will give us our reaction with the sodium carbonate, which neutralises any acid. So that's the effervescence there. We've got the carbon dioxide being formed here. To deal with the precipitate that forms, again we need to look at what we formed. We've got copper ions, we've got nitrate ions. The nitrogen dioxide has been liberated as gas, and the water is a liquid. So this isn't going to do any precipitation. This isn't going to do any precipitation. Copper nitrate, I'm sure you know, is very soluble, so that's not going to precipitate. So we're really only left with the copper ions, which could cause any precipitation. And from your basic chemistry, you should know that copper carbonate is quite insoluble. And so we end up with copper carbonate as a solid, and then this is in the aqueous form, and then this is aqueous as well here. So that's for step 2. The next step, although you're not asked to write ionic equations, it's worth having a look at what's formed in here. In step 3, the precipitate is reacted with ethanoic acid to form solution, which is made up to 250 cubic centimeters of water. So our precipitate, which we've decided is copper carbonate here, this is forming a solution. So our copper ions must be coming out in solution somehow. We've got ethanoic acid going in, CO2H. So again, we've got an acid, we've got a carbonate, so you can see that these two are going to react in a very similar way to up here. So you've got an acid reacting with the carbonate to make carbon dioxide and water. So in this case, we're going to end up with some carbon dioxide. But the interesting thing, why we're interested in doing this, is because it gets the copper back into solution, or into solution. We've got now copper reacting with the ethanoate ions, so we end up with copper ethanoate, which is SO3(2), and that's obviously minus, so we need 2 of those. So if we need 2 of those, we'll need 2 of those, and so to balance it all out, we need a water. So that one won't be in the mark scheme. If we just look at the mark scheme here, obviously step 2 is not asking for anything there, but it's worth thinking about that just so you know what's going on. So, okay, so the last bit in terms of the ionic equations, we're taking some of our sample that we've reacted, we're adding potassium iodide, and we get a precipitate of copper iodide and iodine formed. So if we write out what we know, and then we need to balance it. So from the previous question, we know that we've got copper ethanoate in solution, so we've got copper 2+ solution, so we'll start with that. And we're adding copper iodide, we're adding potassium iodide into that. Okay, aqueous. And that is forming copper iodide as a precipitate, so that's a solid, and some iodine. And that will be aqueous. So if we look at it, we've got a +2 species here, our iodine is a -1 species, here it's -1, copper here is therefore +1, and this is 0. So our copper has been reduced and our iodine has been oxidized, and then you've just got some other iodide ions with a copper 1+. So you've got iodide -1 going to 0, you've got 2 of them, so you've got 2 lots of -1s going to 0, so that's 2 electrons being required. The copper here is going from +2 to +1, so that can only pick up 1 electron, so there must be 2 coppers to balance out that reduction reaction, and so now we've got 1, 2, 3, 4 iodines. You've only got 1 here, so we'll put a 4 in front of that, and so if we were going to balance that out, that would leave us with 4 K+, and then as we're only interested in having a ionic equation, we end up with just copper 2+ aqueous. Sorry, balance that as well, so 2 of them. Potassium ions don't do anything, so we just got 4 I-, aqueous, becoming 2 copper iodized solid, and then I2 aqueous. Okay, so if we just check that with the mark scheme, 2 copper ions, 4 iodides, 2 copper iodides, and iodine. So that's what we'd expect. So that's the ionic equations. That deals with that part of it. So the next bit, determine the percentage by mass of copper in the brass, give your answer to 1 decimal place. So work backwards from the end to see what reactions we've got. So we've got iodine reacting with thiosulfate, S2, 3, 2 minus, becoming iodides, and the S406, 2 minus, and then our previous equation, which we worked out on the previous page, is one we want. So 2 copper, 2 plus, and 4 iodide minus, becoming 2 copper iodides and iodine. So they're the only equations we need to worry about. So we've got a 1:2 ratio here of the iodine to the thiosulfate, and our copper ions are producing our iodine, and then our iodine is reacting with the thiosulfate, and that's the titration here. So the ones we're interested in is our copper 2 plus, because this is the one that we are trying to work out ultimately. That produces in a 2:1 stoichiometric ratio, 2 copper 2 plus ions makes 1 iodine, and then 1 iodine reacts with 2 thiosulfates, S2O3, 2 minus. So the ratio is 2:1:2, and so the ratio we're really interested in is the copper ion ratio to the thiosulfate ion ratio, and so you can see that that's just a 1:1 ratio, S2O3, 2 minus. So if we can work out the concentration of this, we can work out the concentration of that, and then we can work backwards to work out the mass of copper. So let's do that. We've got an average titer of 29.8 cubic centimeters, and we've got a volume here of 0.1 moles per decimeter cubed. So number of moles, concentration times volume, so 0.1 times 29.8 over 1,000. So that gives us 2.98 times 10 to minus 3 moles of S2O3, 2 minus, and because we've got a 1:1 ratio here, straight away we can say that we've got the same number of moles of the copper ion, Cu2 plus. Now if we track back, we use 25 cubic centimeters of solution, but that originally came from 250 cubic centimeters, so we know that we've got 2.98 times 10 to the minus 2, so 10 times as much of Cu2 plus in the brass sample, because all of the brass sample was reacted, ended up in the 250 cubic centimeters, which we use 1/10 of in the titration. And now that we know the number of moles, we just need the relative atomic mass of copper, which is 63.5. So the mass of the copper is now 63.5 times 2.98 times 10 to the minus 2, which gives us 1.89 grams. And finally, we want to work out the percentage by mass of the copper in the brass to 1 decimal place. So the percentage by mass is 1.89 over 2.80 times 100, which gives us 67.6%. Okay, and then just check that with the mark scheme. 67.6%, and then all the workings there. Okay, so hopefully that's helpful. Any more questions, just drop me an email and I'll get back to you as quick as I can.